Assalamu alaikum, my dear students. I hope all you are well at your home. I am Setu. I am the senior teacher of mathematics, Milestone School and College. We all know we are passing very much tough day for this disease. In the meantime, Milestone School and College initiate a very great process for this online class. This would be very much helpful for you to continue your study at your home. You can look after the online CW and submit your SW in the comment. This is a very much continued process for your study. So let's start today's class. My dear students of class 8, welcome to video class on mathematics. I am Setu. I am the senior teacher of mathematics. Today I am going to discuss chapter 9, Pythagoras Theorem. That is very important chapter for you, and every year in JSC there is a creative question from this chapter. So this chapter is very important, and you have to understand this chapter more clearly, and I will try my best to make you understanding. Let's start now. At the end of this lesson, you will be able to explain right angle triangle, prove Pythagoras theorem with the help of two right angle triangles, proof of Pythagoras theorem, proof of Pythagoras theorem with the help of similar triangles, proof of Pythagoras theorem by the algebraic proof, proof of converse Pythagoras theorem, basic discussion. In the 6th century BC, Greek philosopher Pythagoras discovered a special property of right angle triangle. This property of right angle triangle is known as Pythagoras theorem. Right angle triangle. We know that the sides of a right angle triangle have got special names. Let's see what are the special names. The sides opposite to right angle as hypotenuse. That means this is a right angle triangle, and AB is opposite of right angle, so this is the hypotenuse. That means AB is the hypotenuse. The sides containing the right angle as base and height. It means other two sides. This BC is the base and AC is the height. So in the figure, ABC is a right angle triangle where angle ACB is a right angle equals to 90 degree. That means on right angle equals to, we know, 90 degree. AB equals to C is the hypotenuse. BC equals to A is the base. That means this alphabet, small alphabet CA, we just make it let. That means let AB equals to C, let BC equals to A, and AC equals to B is the height. Now, key points of Pythagoras theorem. The sum of squares of two sides is equal to the square of the measurement of the hypotenuse. For better understanding, I am using some examples. from the above figure the sides A, B and hypotenuse C, then C square equals to A square plus B square. From this language we get the sum of squares of two sides. The sum of squares of two sides, that means A square plus B square, is equals to the square of the measurement of the hypotenuse, and it is equal to the square of the measurement of the hypotenuse, that is C square. Example, suppose in a right angle triangle two sides are A equals to 3 cm, B equals to 4 cm, then hypotenuse C will be, we have to use this formula for finding C or hypotenuse. That is the formula. And putting the value of A and B, we get C square equals to 9 plus 16, C square equals to 25, and we know C equals to root over 25, that is 5 cm is the hypotenuse. This is the formula, or this is the key points of Pythagoras theorem. Now, Pythagoras theorem. In a right angle triangle, the square on the hypotenuse is equal to the sum of the squares on the two other sides. That means this language and this language are the same. This Pythagoras theorem has been proved in various methods. See the first method. Proof with the help of two right-angled triangles. You can see from the figure in here there are two right-angled triangles. These signs are right-angle triangle sign. That means triangle ABC, triangle CDE are right-angle triangle. Proposition: let in triangle ABC, at first we have to think about this triangle only, ABC, only this triangle, and after the construction we will get these two triangle. Okay, so let in triangle ABC, angle B equals to 90 degree, hypotenuse AC equals to B, height AB equals to C, base BC equals to A. It is required to prove that AC square equals to AB square plus BC square, or we can write AC means B, B square equals to AB means C, C square, BC means A square. So it is required to prove that. Now construction. Produce BC up to D. In here from the figure you can see produce BC up to D such that CD equals to AB. That means we have to draw like this, CD equals to AB. That means AB and CD, they are the same. Draw a perpendicular DE at D. That means this D point, in point D we have to draw a perpendicular DE at D such that DE equals to BC. That means DE equals to BC. We have to draw like this, that DE equals to BC. Join CE and AE. So after joining CE and AE we got another triangle ACE. And I'm going to tell you one thing, that whole thing ABDE, this is the whole thing, and in this, in here three triangle, you can see ABC, CDE and ACE. Let's see the proof. This is the proof. At first we have to prove the congruence of triangle ABC and triangle CDE. As you remember, just before we have done CD equals to AB, DE equals to BC, so it is very easy to prove the congruency of these two triangles. In triangle ABC and triangle CDE, AB equals to CD, AB equals to CD, from the construction we know, BC equals to DE, BC equals to DE from the construction we know, and included angle ABC equals to included angle CDE because they are right angle. So we already got side angle side, that means two sides and an angle are equal, so we can say triangle ABC congruence of triangle CDE. So from this congruency we can write AC equals to CE, the rest of the part AC equals to CE, and angle BAC equals to angle ECD, angle BAC equals to angle ECD. For finding these two things we require to prove this congruency. Okay, now number 2, again AB perpendicular BD, AB perpendicular BD already you know, and ED perpendicular BD, and ED also perpendicular on BD, as you can see from the figure. So we can write AB parallel ED because perpendiculars on the same base are always parallel. This is the new thing, you have to remember this. This is the formula also. Perpendiculars on the same base are always parallel because BD is the same base and AB and ED is the perpendicular. So we can say perpendiculars on the same base are always parallel. So therefore AB parallel ED. Now in quadrilateral ABDE, this is the quadrilateral ABDE, AB and ED are parallel but not equal. As you can see from the figure, AB and ED, they are parallel but they are not equal. So this quadrilateral we can say ABDE is a trapezium because we know what is trapezium. In a quadrilateral, if two perpendicular are parallel but not equal, then you can say that quadrilateral is a trapezium. Now number 3, since angle ABC equals to one right angle, you can see from the figure angle ABC equals to one right angle, therefore angle ACB plus angle BAC equals to one right angle. So angle ACB plus angle BAC equals to one right angle because we know in any triangle angle ACB plus ECD plus ACE equals to 180 degree. That means the sum of three angles of a triangle equals to 180 degree. If one angle is 90 degree, the other two angle, the sum of other two angle obviously on right angle. Therefore angle ACB plus angle BAC equals to on right angle, or angle ACB plus angle ECD because we got from this. Therefore since angle BAC equals to angle ECD, as you can see from the above, angle BAC equals to angle ECD, so you can write instead of angle BAC you can write angle ECD. So angle ACB plus angle ECD equals to on right angle. So angle ACE equals to on right angle. Triangle ACE is a right angled triangle. Number 4. How? Because since you can see angle ACB plus angle ECD equals to on right angle, so the other angle you can see ACB and ECD, so other angle will be ACE because on a straight angle, if we think there is a on a straight angle, so the three angle is angle ACB, angle ACE and angle ECD. So if angle ACB and angle ECD equals to on right angle, so obviously angle ACE equals to on right angle, as you can write in here, you can see. Therefore triangle ACE is a right angle triangle, so ACE also a right angle triangle. So in here we get three right angle triangle, ABC, ECD and ACE also a right angle triangle. Now the area of trapezium ABDE. In here ABDE is the area is a trapezium. So we know the area of trapezium equals to area of these three triangle, the sum of these three triangle. So this is the new thing, you have to memorize it. The area of trapezium ABDE equals to area of triangle ABC, triangle ACE and triangle ECD. Now area of trapezium half AB plus DE into BD. In here you can see area of trapezium equals to half sum of parallel sides. That means AB and ED are parallel sides, and distance between the parallel side, and BD is the distance between parallel sides. So this is the area of trapezium ABDE, the formula. And in here there are three triangles, and we have to write down the area of these three triangles. And we know the area of triangle, the formula is half into base into height. We know base equals to A, height equals to C. So for triangle ABC, base A, height C, so half AC. In triangle ECD, base C, height A, so we will write half AC. And in triangle ACE, base B, also height also B, so that would be half B square. Now, or half AB plus DE, and instead of BD we can write BC plus CD. You can see instead of BD we can write BC plus CD equals to half AC plus AC, because we will take common half in here, AC plus AC plus half B square. Or half, now we will write down the small alphabet. Instead of AB we can write A, instead of DE we can write C, instead of BC we can write A, instead of CD we can write C. From the figure you can see half 2AC, because AC plus AC equals to 2AC plus half B square. Half A plus C whole square, because in here there are 2A plus C. Half 2AC plus B square, because if we take common between these two we can write 2AC plus B square. Or A square plus 2AC plus C square. This is the formula of A plus B whole square. That's the general formula. We can write A square plus 2AC plus C square equals to 2AC plus B square. And where is half gone? Because there is a half in two sides, so we can write omitting half from both sides. You can write omitting half from both sides. Now if we exchange the side, A square plus 2AC plus C square minus 2AC equals to B square, and we can reduce 2AC and 2AC because plus and minus sign. We get A square plus C square equals to B square. Therefore we can write B square equals to A square plus C square. That is the proof with the help of two right angle triangle of Pythagoras theorem. So my dear students, I have discussed the theorem from Pythagoras, and I am tried to prove this theorem. We'll use little bit more step to make you better understanding. I think this will help you very much. So please observe my video very carefully, and more you will understand these theorems very easily. And we will meet again chapter 9. Okay, so I am Setu. This is enough for today. Stay home, stay safe. Assalamu alaikum.